My dear children, how are you? I hope you are fine. You are going to write your half-yearly examination. First of all, I wish you children all the best. Give your best in your half-yearly examination. Okay. Practice all the sums in your rough note one time at least. One time you have to do all the sums in your classwork as well as in your homework. Okay. And see your exam question for subject mathematics. Chapter 2 whole numbers, chapter 3 playing with numbers, and chapter 5 fractions up to third. So that is till third you have to practice these 3 chapters. Okay. And see your question pattern. Choose 10 marks. That is you have 10 into 1, 10 marks for choose, and fill ups 5 questions. 5 into 1, 5 marks. 3 marks there will be a choice. Among them you have to answer only 5 questions. So 5 into 3, 15 marks. And 5 marks also you have the choice. Among them you have to answer 4 questions. So 4 into 5, 20. So totally you are going to write 50 marks for your half-yearly examination. Okay, 20, 35, 40, 50. Okay. First we are going to recall the chapter 2 whole numbers. Okay. Now we are going to just revise the concept which we have already discussed in the chapter. First we are going to see natural numbers. What is the another name for natural numbers? Counting numbers. Okay. What are the natural numbers? 1, 2, 3, 4, etc. It was going on. Such numbers are said to be natural numbers. And my question is, what is the smallest natural number? Yes, 1 is the smallest natural number. And what is mean by whole numbers? Along with natural number, if you add 0, we get whole numbers. So 0, 1, 2, 3, 4, 5, etc. are called whole numbers. These are endless. Okay. So which is the smallest whole number? 0. So the smallest natural number is 1. Smallest whole number is 0. Okay. Next we are going to see the concept successor and the predecessor of a number. How do you find the successor and the predecessor of a given number? By adding 1 to the given number, we get successor of the given number. Similarly, if you subtract 1 from the given number, we get the predecessor of a given number. Suppose the given number is 5 means 5 minus 1, 4 is the predecessor. 5 plus 1, 6 is the successor of the number. Okay. Also in the unit test 2 itself, we have discussed about the properties of whole numbers and also the playing with numbers chapter. Okay. So you just go through the properties of whole numbers. What are the properties we have discussed? Closure property, commutative property, associative property, identity, distributive property. These are the properties we have discussed on whole numbers. These properties we have discussed on the based on 4 operations: addition, subtraction, multiplication as well as division. Okay. For closure property we have to take 2 elements. For commutative property also we have to take 2 elements. For associative property we have to take 3 elements, single operation. Identity. While we speak with identity, you have to remember these 2 things. Okay. Dash is the additive identity of whole numbers. That is, in the operation of addition, which number is said to be identity element. We can also call that number as a additive identity. Dash is the additive identity of whole numbers. It means if you add any number with that identity, you get that same number. So which is the answer? So what is the answer? Yes, 0. 0 is the additive identity of whole numbers. If you add any number with 0, you get that same number only. So we are calling that number as a additive identity. Why we call the number as additive identity? Because we are using the operation addition. Okay. Next, what is this dash is the multiplicative identity of whole numbers. Similar explanation, but here we have the operation multiplication. What should be that is, if you multiply any number with 1, we get the same number. So we can call 1 as the multiplicative identity. If you add any number with 0, you get that same number. Similarly, if you multiply any number with 1, you get that same number. For example, 0 into 1. What is your answer? 0. So you have to write like this: 4000 into 0. It is also 0. See here, 9,999. This is the biggest 4-digit number. If you multiply any number with 0, you get the answer 0 only. Okay, so remember this thing in your mind. And also we have discussed about the distributive property. What is the distributive property? You have to take 3 elements and 2 operations. So you just go through your classwork about that properties. Okay. So remember these 2 things, children. Dash is the additive identity of whole numbers 0. Dash is the multiplicative identity of whole numbers 1. Okay. And next an important concept is Bode-Mass rule. What is meant by Bode-Mass rule? Already we have discussed. This is an important rule. Definitely you have the impact of Bode-Mass rule up to your higher secondary education. So give importance to this Bode-Mass rule. Okay. What is meant by B? B stands for brackets. O stands for half or order. A and D for division. M for multiplication. A for addition. S for subtraction. So Bode-Mass is just a rule which gives how to evaluate the problems which are involved in more than 1 or 2 operations. Okay. And once again we have to regard the types of brackets. What are the types of brackets we have seen? Vinculum, simple brackets, curly brackets and square brackets. These are the types of brackets we have discussed. In the process of evaluating the sum, first you have to evaluate this bracket, that is vinculum bracket. Second, you have to evaluate the simple bracket. Third, you have to evaluate the curly bracket. At last, you have to evaluate the square brackets. After evaluating the brackets, you have to go for the operation of. Of means multiplication. Okay, and then you have to go for the division, and then multiplication, and then addition as well as subtraction. Okay. Now we are going to do one sum based on the Bode-Mass rule. Okay. See the question, children. 4 plus 9 minus 7 plus 2 minus 1. See here, children, here we have the 4 types of bracket. See, vinculum, simple, curly and square bracket. So as per the Bode-Mass rule, first we have to evaluate the bracket. Among the bracket rules, first we have to evaluate the vinculum bracket. So under the vinculum, we have the number 2 minus 1. So what is the answer for 2 minus 1? 2 minus 1, 1. Thus we have evaluated the vinculum bracket. Okay, next we have to evaluate the simple bracket. So within the simple bracket we have 2 numbers with operation addition. So we have to add that. So 4 plus 9 minus 7 plus 1. What is your answer? 8. Okay. And then close the bracket by using curly and square. Okay, thus we have evaluated the simple bracket also. Now we have to remove this bracket. So 4 plus 9 minus 8. So next we are going to evaluate the curly bracket. Within the curly brackets we have 2 numbers with operation subtraction. So 9 minus 8, 1. Now in this step also I have removed the bracket and write the answer. So 4 plus 1. So what is your answer? 5. Thus we have simplified this sum. Okay, in the question paper whether they are giving use the Bode-Mass rule or not, simply giving the question as evaluate or simplify means definitely you have to use the Bode-Mass rule only. Okay. Also remember, children, if you divide any number by 0, its answer is not defined. See here, 3493 divided by 0. So what is your answer? Not defined. See here, 73 divided by 0. So what is the answer? Not defined. If you multiply any number with 0, you get the answer 0. If you divide any number by 0, your answer is not defined. Definitely you have to remember this in your mind. Okay. Now we are going to revise chapter number 3, playing with numbers. Okay. First we are going to revise about even numbers. What is meant by even numbers? Numbers which are divisible by 2, or we can also define it as numbers which are multiples of 2. Okay, see here, divisible by 2 are called numbers which are divisible by 2 are called even numbers. Also the number which are multiples of 2 are called even numbers. What are the even numbers? 2, 4, 6, 8, 10, 12, 14, 16, etc. These numbers are said to be even numbers. Okay. How can you identify the given number is a even number? For example, if the given number is 243 means, how can you say this is a even number? How can you say? See here, units place place of even numbers is any one of 0, 2, 4, 6 or 8. Okay. So see here which is the units place. This is the units place. Ones, tens, 100. So here in the units place we have the number 3. If it is an even number means it will be ends with 0 or 2 or 4 or 6 or 8. See here we don't have such number. So this is not a even number. Suppose if I write like this means see here now the digit in the units place is 4. We know that if the number ends with 0 or 2 or 4 or 6 or 8, it is a even number. So this is a even number. Okay. Next we are going to see odd numbers. What is mean by odd numbers? Odd numbers are the numbers which are not divisible by 2. Okay. See here what are the odd numbers? 1, 3, 5, 7, 9, 11, 13, etc. If a number is not even means definitely it is a odd number. See here we have 1, 2, 3, 4, 5, 6. So if it is a even number means if it is not a even number means it is a odd number. If it is not a odd number means it is a even number. Okay. How can you identify given number is a odd number? See here unit place of odd number is 1 or 3 or 5 or 7 or 9. For example, suppose 273 means digits in the unit place is 3. Suppose if a number ends with 1, 3 or 5 or 7 or 9, we can call them as a odd number. So we can call this number as a odd number. Suppose if it ends with 4 means or ends with 0 means it should be a even number. If it ends with 1 or 3 or 5 or 7 or 9, it is a odd number. Okay. Next we are going to see important concept prime numbers. What is mean by prime numbers? The number which are divisible by 1 and itself. Such numbers are said to be prime numbers. We can also define the prime numbers as numbers that have only 2 factors. What are the 2 factors? One of the factor is 1 and another factor is the number itself. Such numbers are called prime numbers. Okay. Numbers that have only 2 factors. The 2 factors are 1 and the number itself. Such numbers are said to be prime numbers. What are the prime numbers? 2, 3, 5, 7, 11, 13, 17, 19, etc. It was going on. Such numbers are said to be prime numbers. Okay. Next we are going to see composite number. What is mean by composite numbers? Numbers which have more than 2 factors. Here, numbers which have only 2 factors are said to be prime numbers. Here, the number which have more than 2 factors are said to be composite numbers. Okay. See here we have 2, 3, 5, 7, 11. We can also say the number which are not prime are composite. So here we have 2, 3. So here we have the first composite number is 4. So we have a doubt. What about the number 1? We can say the 1 is neither prime and nor opposite. 1 is neither prime and nor composite. It means 1 is not a prime number and 1 is not a composite number. It is a exceptional case. Okay, leave the number 1. See here we have the 2, 3. What is the 4? 4 is the composite number. 5 is a prime number. What is the next number? 6. 6 is the composite number. 7 is the prime number. 8 is the composite number. 9 is the composite. 10 is the composite. 11 is the prime number. So if a number is not prime means it is a composite number. See here these are the examples of composite numbers. See 4, 6, 8, 9, 10, 12, 14. So we can call this number as a composite numbers. How we are calling these numbers? Because 4 can be divided by 4 and also it is divided by 1 and also it is divisible by 2. So it has 3 factors. So we can say numbers which have more than 2 factors are said to be composite numbers. Similarly, every numbers have more than 2 factors. So we are calling this number as composite numbers. Remember this concept, children. These are very important concepts. Okay. Next we are going to see another number. Dash is the only even prime number. See here. These are the even numbers and these are the prime numbers. What is the question? Dash is the only even prime number. So that number should be even as well as the prime. What is the number? Yes, 2. 2 is the only even prime number. So what is your answer? 2. These are the important one more. Remember this. Okay, so one is neither prime nor composite. It means one is not a prime number, one is not a composite number. And dash is the only even prime number. 2. 2 is the only even prime numbers. Okay. Next we are going to see divisibility test. Okay. These are the very basic concepts. So remember this. How can you identify the given number is divisible by 2? See here. Which numbers are divisible by 2? All the even numbers are divisible by 2. All the even numbers are divisible by 2. How can you find the even numbers? Number ends with 0, 2, 4, 6 or 8 are said to be even numbers. Okay, for your problems you have to refer your class up. You have to do the sums as per in the class up. Okay, so what is the concept of divisibility by 2? If it is a even number, it is divisible by 2. How can you find the given number is a even number? If a number ends with 0 or 2 or 4 or 6 or 8, it is a even number. Okay. Next we are going to see divisibility by 3. It is very important. How can you find the given number is divisible by 3? For that you have to sum the given number. That is, sum of the digits is divisible by 3. The given number is divisible by 3. What is mean by sum? Sum means add. Suppose this is the given number 543. We have to check 543 is divisible by 3 or not. For that you have to add them. 5 plus 4, 9. 9 plus 3, 12. So you get the answer 12. So 12 is divisible by 3. So the given number 543 is divisible by 3. Do you understand children? Suppose if you add one more number to this given number, what happens? It becomes 13. But 13 is not divisible by 3. So we can say 5431 is not divisible by 3. That is, to check whether the given number is divisible by 3 or not, you have to sum the digits. If the sum is divisible by 3, the given number is divisible by 3. If the sum is not divisible by 3, the given number is not divisible by 3. Okay? I hope you understand. Next we are going to see divisibility by 5. It is a very easy concept. If a number ends with 0 or 5, if it is then it should be divisible by 5. If a number ends with 0 or 5, then we can say it is divisible by 5. Okay. Next we are going to see the concept HCF and LCM. What is meant by HCF? HCF means highest common factor. How do you find the HCF of a given number? By using the prime factorization method, we can easily find the HCF of given numbers. See here, find the HCF of 12, 20 and 36. First we are going to factorize the given number. How do you factorize the 12? By using the prime numbers. What are the prime numbers? 2, 3, 5, 7, like that. These are the prime numbers. In the process of prime factorization, you have to use only the prime numbers. Okay. 12 comes in 2 tables. How many times? 6 times. So 6 2s are 12. Again you have to use the number 2 because it is a even number, so it is divisible by 2. So 6 comes in 2 table. How many times? 3 times. Again 3 because 3 is a prime number, so it is divisible by itself only. So 3, 1. Thus we have factorized the number 12. So we have to write 12 equal to 2 into 2 into 3. Next we are going to factorize the number 20. Since it is a even number, so it is divisible by 2. So 1, 2 is to bring down that 0, 0. And then it is also a even number, so it can be divisible by 2. So 5 2s are 10. 5 is a prime number, so divided by 5. So thus we have factorized the 20. 2 into 5. Next 36. So it is a even number, so we can use the prime number 2. So 1, 2 is 2. What is the remainder? 1. 16. 16 comes in 2 table how many times? 8 times. Again use the number 2. 9 2s are 18. 9 is divisible by 3. 3 3s are 9. Again is 3. Thus 1 time. Thus 36 is factorized as 2 into 2 into 3 into 3. After factorizing the given numbers, how can you find the HCF? By rounding off the common factors. 2, 2, 3. These are the prime factors of 12. And similarly, these are the prime factors of 20. These are the prime factors of 36. We have to find the highest common factors. Further, you have to round off the common factors. These are the common factors. There is no other common factors. So once again, you have to write one time of the common factors and then find the product of it. So for this 3, 2, you have to write 1, 2. For this 3, 2, you have to write 1, 2. So 2 2s are 4. Therefore, HCF of 12, 20 and 36 is 4. It's clear, children? Next we are going to see LCM. What is meant by LCM? Least common multiple. Now we are going to find the LCM of 12, 20 and 36. How can we find the LCM of this? To find the LCM of the given numbers, we have to factorize prime factorize the given numbers simultaneously. Further, you have to write the number like this. And you have to use only the prime numbers to factorize this. See here, all the numbers are even numbers. So we can use the table 2 to divide this. So 6 times, here 10 times, here 1 2 is to remember 1, 8 2s are 16. Again we got the even numbers. So use 2, 3 times, 5 times, 9 times. See 3, 5 are prime numbers. So use 3 to divide it 1 time, write the 5 as it is, and 9 comes in 3 table 3 times. Next we use 3, write the 1 as it is, write the 5 as it is, 1 3 is 3. Next use 5, 1 time, 1. Write the 1 right as it is, and 5 comes in 5 table 1 times. Thus we have factorized the given number. Next we have to find the LCM of 12, 20 and 36. How can we find the LCM of the given numbers? By multiplying these factors. What are the factors? 2 into 2 into 3 into 3 into 5. 2 2s are 4. 3 3s are 9 into 5. So 5 4s are 20 into 9. So forget the 0. 9 2s are 18. Now add the 0. Thus LCM of 12, 20 and 36 is 180. That is among the common multiples of 12, 20 and 36. 180 is the least common multiple. So LCM of 12, 20 and 36 is 180. Okay. Next we are going to see an important note, children. Definitely you have the one more concept. Okay. Product of any two numbers. Suppose you are considering two numbers means, if you are producting that number means, it should be equal to product of their HCF and LCM. It's clear, children? Product of any two numbers is equal to product of their HCF and LCM. Okay. Next we are going to revise the chapter 5 fractions. Okay. What is meant by fractions? Fraction is a part of a whole. The whole is either a single object or a collection of objects. So fraction is a part of a whole. It contains numerator as well as a denominator. So fraction equal to numerator by denominator. Also we have discussed about types of fractions. What are the types of fractions? Based on the values of numerator and denominator, we can classify proper, improper, mixed, unit, like and then unlike fractions. What is meant by proper fraction? If the numerator is less than denominator, see here numerator value is less than its denominator, such fractions are said to be proper fractions. Similarly, if the numerator is greater than its denominator, such fractions are said to be improper fraction. Okay. What is meant by mixed fraction? Mixed fraction is a combination of a whole number and a proper fraction. See here, it consists a whole number as well as a proper fraction. Such fractions are said to be mixed fraction. Proper, numerator is smaller than the denominator. Improper, numerator is greater than its denominator. Mixed, it consists of whole part and a proper fraction. Okay. Next we are going to see unit fractions. What is meant by unit fractions? If the fractions have number 1 in its numerator means such fractions are said to be unit fractions. See here 1 by 2, 1 by 3, 1 by 7. All the numerators are 1. So we can call these fractions as unit fraction. What is meant by like fractions? If the denominators are same, for example 1 by 3, 2 by 3, 5 by 3, see all the denominators are same. Such fractions are said to be like fractions. What is meant by unlike fractions? If the denominators are different, for example 3, 13, 30, see the values of denominators are differ with each other. Such fractions are said to be unlike fraction. Do you understand, children? What is meant by fraction? Fraction is a part of your whole. The fraction contains numerator as well as a denominator. Based on the value of numerator and denominator, we are classifying proper, improper, mixed, unit, like and unlike. Next, we are going to see how to add and subtract the fractions. See here. Here we have taken only the like fractions. If it is a like fraction means we can easily add or subtract it. Okay. Suppose the given fractions are unlike fractions means we should convert them into like fractions and then we have to add or subtract. Okay. See the first sum 5 by 6 minus 1 by 6. See the observe the denominator, they are same. So it is a like fraction. So we can add or subtract it. Here the given operation is subtraction. So we are going to subtract it. How can you subtract the like fractions? By subtracting their numerator. So you have to subtract only the numerator. Don't subtract the denominator. So 5 minus 1 by 6. So what is the answer? 5 minus 1? 4 by 6. You can also cancel it 2 times, 3 times by using the 2 tables. So your answer is 2 by 3. Thus we have subtracted the given numbers, given fractions. See the next one 1 by 4 plus 2 by 4. So both are like fractions. So we can add them. How can you add these two like fractions? By adding their numerator. So 1 plus 2. So what is your answer? 3 plus 4. Okay, see the next one 7 by 9 minus 3 by 9. So these are also a like fractions. We can add these two like fractions. We can subtract these like fractions by subtracting their numerator. So 7 minus 3. What is the value of 7 minus 3? 4 by 9. So if the given fractions are like fractions means it is very easy to add or subtract. Suppose if the given fractions are unlike, what we have to do? We have to make them into like fractions. How can you make them into like fractions? By taking LCM of the denominators. What are the denominators here? 10 and 15. So far we have discussed how to find the LCM. So we are going to find the LCM of this. So 2 times, 3 times. Since they are prime numbers, 1 times 3, again 3, 1. Thus we have factorized the given denominator. So LCM of 10 and 15 are 2 into 3 into 5. 5 2s are 10. 10 into 3, 30. So we got the LCM as 30. Now we are going to convert this 7 by 10 and 2 by 15 as a like fractions. How can you convert? See here, first you have to consider the first fraction 7 by 10. Write like this 7 by 10. What should be multiplied with 10 to get the LCM 33? So multiply denominator and numerator by 3. So we get 7 3s are 21, 10 3s are 30. So this is the way you have to find the equivalent fraction also. Also you have the problems based on equivalent fraction. You know that method already. Okay, revise that sum also. Okay, and write the next fraction 2 by 15. So what should be multiplied with 15 to get the LCM 30? See here 5 3s are 15, 15 2s are 30. So the number is 2. So multiply the denominator as well as the numerator by 2. So 2 2s are 4, 15 2s are 30. Thus we have converted the given fraction into its equivalent fractions by making the denominator same. So they became the like fraction. Now once again you have to write the question 7 by 10 minus 2 by 15, which is equal to, what is the value of 7 by 10? 21 by 30 minus, what is the value of 2 by 15? 4 by 30. Thus we have converted the given unlike fraction into like fractions. Now it is very easy to subtract these two like fraction. How do you subtract the like fraction? By subtracting their numerator. So 21 minus 4, 20 minus 4, 16, 16 plus 1, 17. So your answer is 17 by 30. Next, how can you write the half-yearly examination? See dear children, you must use unruled paper for writing your maths examination. Okay, you have to use only the blue ink pen to write your answers. Don't write the questions, right? Choose the best answer, fill ups, answer the following. No need to write the headings, okay? And write the question number as in the question paper. Don't give your own number to the questions. Write the question number as in the question paper, okay? And also do the rough work if necessary, okay? All the best children. Thank you.